In this video, we're going to solve two logarithmic equations, and we'll be using some properties of logarithms. Let's go over the main ones we're going to be using. Of course, you have the definition of log. Log of x to base a is equal to L. That's your logarithm. Means that x has to be equal to the base, in this case a, taken to the L power. Then we have this one here. You have the log of some number m to the r power to base a. You can bring this exponent out in front and make a coefficient, and vice versa. And then you have the change of base. You have any log of some number m to any base a. You can write that as the log of m. You pick another base, whatever's convenient. So log of m to base b over the log of whatever this base is, in this case a, to the base you chose. These have to be the same. So for the first one, we have the log of x, and the exponent is the log of x to base 2, and of course you have the base 2 over here. So you can think of this as an exponent, and property allows me to take this as a coefficient. So I can rewrite this as the log of x to base 2. So this comes out in front. I'll put this in parentheses. And then what's left? Well, we have left the log of x to base 2 equals to 4. So here we're just multiplying. Log of x to base 2 times the log of x to base 2 here gives me the log of x squared, and base 2 here equal to 4. So you have quantity squared is equal to 4. Let's take the square root of both sides. The log of x to base 2, and the square root of 4 could be 2 or minus 2. So let's say plus or minus 2. So we can break this down into the log of x to base 2. So this can equal to 2, or the log of x to base 2 can equal to negative 2. So now we have two equations involving the log of x to base 2. One is equal to 2, the other one is equal to negative 2. So now we're going to use the definition of log. This tells me that this variable here, in this case, so this number x, can equal to this base 2, taken to this value here, this exponent, that can be 2 squared, so this will be 4. And the same way for the other one, the x can equal to 2 to the negative 2. It's going to be 1 over 4, using your rules for negative exponents. So for the first one then, we get x can be or negative 4. And let's do a quick check here. If we put a 2 here, or say 4 rather, if I put a 4 here, and a 4 where the x is here, then the log of 4 to base 2 is 2, because 2 squared is 4. So this is just a 2 here, and this is a 4 here. So 4 squared is 16, and 16 does equal to 2 to the 4th power, so this one checks. And then for the next one, I'm going to write it in completely so you can see here. It's the log to base 2, and in this case, and this is positive 1/4 here. So this will be 1/4 here for the x. And then this x right here, log of x to log of 1/4 to base 2. Let me write it over here. Log base 2. In this case, for the second solution, x is 1/4, so this will be 1/4 here. And then the exponent on this, let me write it separately. It's the log of 2. Log to base 2, I should say, of 1/4. So what is the log of 1/4 to base 2? So this is saying 2 to what power will give us 1/4? Would have to be negative 2. So I put a negative 2 here. 1/4 to the negative 2 power will give me 16. The log of 16 to base 2 does equal to 4, which is what we have over here. So that one checks. So the answer does work out here, x equal to 4 or 1/4. Now for the next one, we have the log of x to base 5 plus the log of x to base 3. We have to change the base here. So I'm going to use the natural log. So this can be written as the natural log of whatever this is x over natural log, have to use the same base, of whatever the original base is. It is 5. So it's natural log of 5. Then it's plus, again, change your base, natural log of x over natural log of whatever the base is. In this case, it's 3. And that's supposed to equal to 1. And then go ahead and factor out the ln of x. ln of x there, ln of x there. So this will give me 1 over ln of 5 plus 1 over ln of 3. And that's supposed to be 1. Then I'm going to come over here, rewrite this. So I got the ln of x factored out, equal to 1 here. Then I'm going to combine these. So the lowest common denominator here will be the product of these two. So it's ln of 5 here times ln of 3. And then it's just like cross multiplying here. So this is ln of 3 here on top, ln of 5. And I'm going to do another step here, ln of x. I have the sum of two logs. Whenever that happens, you can write that as the sum of the product of those values. So this becomes ln 3 times 5 is 15. And that same thing in the denominator, ln of 5, ln of 3. That's equal to 1. So now I want to solve for ln of x to eventually get the value of x. So let's multiply both sides by the reciprocal of this. It'll cancel this on the left side, and I'll have the product of that value on the right. So let's make some room over here. So ln of x then will equal to, multiplying by the reciprocal, both sides, it'll cancel it on the left, and it'll put it over here on the right side. So this will be ln of 5 times ln of 3 over ln of 15. Now we have to solve for x. Remember the base here is e. So again, using the definition of log, this value here, once you have it set up in this particular form, this value here, in this case x, should equal to the base here, which is c, to this power. X should equal to, let me write this big so you can see it, x should equal to this base taken to that power. So this should be ln of 5 times ln of 3 over ln of 15. It was asking for exact answers, so this is actually your exact answer. Ln of 5 times ln of 3 divided by ln of 15. Now should they ask you for an approximate answer, you can use your calculator and take e to this power, and you should get something like 1 to 3 places, 1 decimal. You should get something like 1.921 to 3 decimal places. Thanks for watching. We'll see you next time.